Hey guys, Mr. Midas is here with the last video here on calculus of vector valued functions. So we've got example 2 here. So I'd like to do example 2 for you and then call it a day. So a particle is moving in the xy plane with an acceleration vector now of -2 cosine t, -3 sine t. Time equals 0, its velocity vector is 0, 3, and its position vector is 2 root 2 over 2. So hopefully you're kind of seeing where things are going, right? If I've got an acceleration vector and I need to go back up and find the velocity vector and probably back up again and find the position vector, but I need an initial condition so that way I can find c, because whenever we do an antiderivative, we have a c, so I'm going to need that initial condition. So what is the velocity vector when t equals pi over 4? So we're going to need to do an antiderivative. So the antiderivative of -2 cosine t is going to be -2 sine t plus c, don't forget your plus c, and the antiderivative of -3 sine t is going to be 3 cosine t plus c. All right, and I'm going to say this is c1 and this is c2. I want them to be different c's. Okay, so then I know that at v sub 0, that's 0 comma 3. So I'm going to set that equal to -2 sine of 0 plus c1 and 3 cosine of 0 plus c2. So I'm just going to set each of these equal to each of the components right there. So -2, okay, so what am I going to have here? I'm going to have sine of 0, which is 0, and 0 plus c1 equals 0, so that's going to give me c1 equal to 0, right? And then c2 is going to be cosine of 0 is 1, and 1 times 3 is 3, 3 plus, so 3 plus c2 equals 3, which is going to give me c2 is equal also to 0. So c1 and c2 is 0. So v sub t is going to be -2 sine t and 3 cosine t. And now I want to find that at pi over 4. So I'm going to plug in pi over 4 here. Which is going to be sine of pi over 4 is root 2 over 2. So -2 times root 2 over 2 and 3 times root 2 over 2. All right. So if I wanted to, I can rewrite that as -√2 comma 3 root 2 over 2. And that would be my velocity function there. Okay. The position vector at t equals pi over 4. So now we've got to deal with these components again. So I'm going to go ahead and do the antiderivative. So my s vector here is going to be the antiderivative negative of this guy right here. So I'm doing the antiderivative of this one. So the antiderivative of -2 sine t is going to be 2 cosine t plus a constant. And the y is going to be 3 sine t plus a constant. Did I forget a negative? No, because it's a negative times a negative. Okay, so there we go. We've got each of those. So I have my initial condition here. So I'm gonna go ahead and say 2 cosine of 0 plus c3 is equal to 2, and 3 sine of 0 plus c4 is equal to root 2 over 2. And I'm gonna solve these. So I'm gonna get c3 is equal to 0. And I'm going to get c4 is equal to root 2 over 2 once I solve that out. So my velocity vector is going to be 2 cosine t times 3 sine, oh, I'm sorry, not times, just 3 sine t plus root 2 over 2. Okay. Then I want this at pi over 4, so I'm going to plug pi over 4 in. So 2 cosine pi over 4, 3 sine of pi over 4 plus root 2 over 2, and that's going to give me once all said and done, that's going to be root 2 and 2 root 2. All right, so there you go. That's the position vector at that time. So again, you kind of saw that we were going to do some antiderivatives. So what's the speed at time t equals pi over 4? So the speed, remember, is the magnitude of the velocity vector. So we already have the velocity of pi over 4, so we really only need to find the magnitude of this. So the magnitude of the velocity vector at pi over 4 is going to be equal to the square root of negative root 2 squared plus 3 root 2 over 2 squared. Okay? You can leave your answer like that, or if you really wanted to, you can simplify that a little bit. Square root of 13 over 2, something like that. Okay? All right, so the time when the particle is at rest, we know the particle is at rest when the velocity vector, sorry, not v sub 0, sorry, v sub t is 0, 0, right? So when is the velocity vector 0, 0? That's going to be when negative 2 sine t equals 0, 3 cosine t equals 0. All right, is there ever any time when this is going to happen? This is going to be when time is pi over 2. Oops, sorry. This is when time is 0, and this is when time is pi over 2. Is there anything in common here? Remember that they both have to be the same thing. They both have to be the same. So is it ever at rest because both x and y have to be equal to 0? No, never. Okay, never going to happen. It's never at rest. This thing's going on and on forever. Okay, doesn't want to rest. The direction of the particle when t equals pi over 4, that's going to be theta equals inverse tangent of 2. This is when the particle is at, so the direction. So there's my, I'm going to use that right there. So y over x. So the inverse tangent of 2 is going to be 1.107. All right. So again, a particle is there. This is its position at pi over 4. So I'm going to use the position vector to find this direction. All right, last one, the distance traveled. So the distance, the total distance, is going to be the integral from 0 to 2 of the square root of the velocity vector, so negative 2 sine t squared plus 3 cosine t squared dt. And I'm going to put that in my calculator and get 4.856. All right. And there you go, guys. That's all there's to it. So there was example 2 of vector valued functions, and boom, we're all done with BC Calculus. Have a good day, guys. Talk to you later.